Yeah,
Hi, how are you?
good.
Good. I'm going to stop the broadcast for a sec, I think,
Uh-huh.
because it's starting right now. Or wait, I click on the live button. Is that what I'm supposed to do? What
I
did I do
think
last
so.
time? Meredith?
Hello.
Hi, how are you?
Good. How are you?
I just want to warn you two that I was like really confused on this quiz.
I was too. I'm
Yay.
not the only one.
I'm like, you know what? We're gonna need to work a while on this one because
Yeah.
unless you guys know what you're doing, maybe that's the problem. We're just getting strange answers, and that's what's supposed to happen. I don't know.
Well, the wording's confusing
Yes.
as well.
It is. It seems a little different. Um, I emailed. So, did you guys get my message that I was able to contact, or I mean, he contacted me. Julius contacted me 2 hours after our meeting.
Yes. That's so weird.
I
Did he say what's
know.
going on?
He didn't. I think he assumed, and we didn't really have a chance to figure it all out because he was disconnected. But I think he assumed that maybe he was off on the timing.
Okay.
The figuring out, the adjusting,
Okay.
because it was 2 hours on the dot, and I figure he just might not have been right on that. And then, we were able to work over the quiz together. Like I just have him tell me what he got, and then we were disconnected like 3 questions before we were done. And I tried several times to reach him and wasn't able to. So I don't know. And then I emailed him again last night and this morning to see if he would be able to come or, be at this one, but I'm not sure if I haven't heard back. So,
Okay.
Did he seem like he's understanding things?
yes, he did. There was one question that he had, but it was fairly easy to answer. And then the last 3, like I said, we weren't able to discuss because it was disconnected. So I'm not sure, but it seems to me like he was getting it. I mean, last week's quiz or last session's quiz, I think was pretty easy. At least I thought it was.
Yeah.
And
Right.
maybe he did too. But this next one, I think, is a different story.
Yeah, it's a little. Yep.
Well, that's good. If I had missed this many group meetings, I think I'd be completely lost. So
I
that's
would too.
good that he's still keeping up.
Yeah. I don't know. Should we just go ahead and start? It may be the same. Well, I guess it's only 3 minutes in.
Yeah,
Well, we can start and we can join them in and just catch them up
That's true.
because
That's a
this
good
this
idea.
one was a little bit trickier of a quiz.
Yeah, definitely. We may just have to spend some time working on these problems together.
Right.
Should we just start then?
Sure.
Yep.
Okay. Now I have to apologize. We've been live. So there's a lot of chatter.
All
I'm
right.
not sure. I just haven't figured out how to. Hold on. Let me just find the.
That's all right. We didn't say anything too embarrassing. So.
This is weird because I can see. I can't find the. Oh well, whatever. Okay, so let's go ahead and start officially. I'm Elizabeth Thatcher. This is Group 3, Lesson 7 group quiz.
Sorry, I dropped my headphones.
Oh, introduce yourself, please.
Oh, Meredith Kober, I'm here.
Okay,
And this is Jodi Smith.
awesome. All right. Does anybody care to start?
I will start
Okay.
since I think I knew what this one was.
Right.
All right. Question 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of a z-score of 1.358 and to the left of z-scored negative 1.358. Round your answer to 3 decimal places. So I got 0.175.
Yay! That's what I got too.
Okay, I
Yep.
forgot to round it, so that's good that I read that.
Good job. Yeah. I'll do the next one. Question 4, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? I put the distribution of the sample means.
I did too.
I did too.
Yay. And that's,
but I don't know if I know
But
why.
that doesn't mean
I
it's
know
right.
why. I think I know why.
Okay.
Because of the law of large numbers in my notes, it says, let's see, where is that? As the sample size n gets larger, the sample mean x bar will get closer. No, that's not the answer. It's a different one, but it's something similar to that. It's
I thought I had read something about it, but I can't find it in my notes anywhere. So I must not have written it down, but read it in the.
right.
Well, I figured
had
it
it
was
on my
not the observations because that's not going to change the deviation.
Uh-huh.
So that's why I figured the sample mean.
Where
But
on earth did I?
yeah,
That makes sense.
I have it in my notes, I promise. Okay, let's see. If a sample mean gets smaller, then x will be close to each other. Okay, wait. If the size of the number gets larger, then the standard deviation of the sample mean will decrease. The fraction will get smaller. Does that make any sense?
right. And that's of the large numbers, but I didn't know if that applied because there's only 9 observations.
I see what you're saying, but no matter what it is, it's going to be the standard deviation divided by a number,
Right.
as opposed to the
So it
standard
has to be
deviation.
smaller.
Yeah,
Right.
Okay.
that's why I got that.
logical.
That's my answer.
I'm going to
Okay.
go with that one because I figure it's either that one or it can't be determined.
Yeah. Okay.
All right. Yay, I get question 5. Okay. It's okay. Which of the following results implies that the spread in x decreases as the sample size increases? That is the law of large numbers.
Yes. That's what I put.
So is that referring to the same thing we just talked about?
Yes.
That's what I
But the
thought.
spread is your standard deviation, right?
Right.
Okay.
Yes.
Again, from my notes, let me I should have stayed on that page. I don't know. It just made sense to me. I can't remember how sometimes when I'm on the spot, I can't think.
Right.
Implies that this.
Well, I put that same answer. I'm just not
Okay.
confident in my understanding completely yet. But
Yeah, I have to say I'm not either. Clearly.
I need to go over everything anyway.
Yeah. Okay.
No, just kidding. I found something else. Never mind.
As a sample size. Hold on. Do you want me to keep looking in my notes? Or do we want to go
No,
on?
I think I
Okay.
get it. I'm just not quite sure why I get it.
Okay. All
I'll
right.
go over my notes later on.
Okay.
Right.
All right. So here is where the confusion starts for me.
So it's my turn again, right?
Yes, ma'am.
Okay, so use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. So question 6. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Okay, so that would be 160 minus 150.8 divided by 8.8, correct?
Mm-hmm. Yeah, that's what I
So I
put.
got 1.045.
Correct.
Oh,
Okay.
did I just do that 1.045? I think okay, so 6, 1, oh, you know what I did? I did 160. Wait. Tell me again how you did that, because I have the wrong answer.
So that's just the first equation we knew about. So it's
Okay.
x minus
Which is 160 minus 150.8.
0.8 and divided by 8.8.
Okay.
But there's no n to deal with. We can't use the
Right. So then I have I have 10.8 over 8.8. And then I divide that.
Should be 9.2 over 8.8.
Oh, I see. Okay, 9.2. Gotcha.
Yeah, don't forget the 0.8.
Yes. Okay. 9.2 divided by 8.8. Oh my gosh. 1.045. Yes.
Correct.
Yep. Okay.
And we just leave it as that. We're not rounding or anything.
Right.
All right. Elizabeth, do you want to take 7?
Sure. I have a, okay. What's the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Round it to the nearest 3 places. So I did the wrong answer, of course. Remember on my last one. So I'm going to just plug it in right now.
Right.
1.045. And then what was it asking again?
It's above, so it's just shaded to the right.
The far right only. Okay.
Right.
So it's 0.140. I'm sorry, 0.140? 148.
I got 0.1480.
Yes.
Me too.
Yes. I'm sorry. I just didn't like this.
Okay, so that it's just going to be 0.148, correct?
Yes.
You guys always put the 0 before 0.148, or?
I do.
Okay.
I do, but I think it'll give it to you either way.
Okay.
Yeah.
All right. Is it okay if I move on to question 8?
Yes.
Okay. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What does the z-score correspond to the sample mean of these student scores? So this is what I did. So I added up those scores and divided by 5 to get the mean of 160.
Uh-huh.
And so I did 160 minus 150.8 divided by 8.8. But it's asking for the sample mean. So does that mean then I do the 8.8 divided by the square root of 5?
Ah.
Where did you get 150.8?
From the question above it, how it's
The information above question
yeah.
6 goes to all of them.
Oh my goodness. That changes everything. Okay.
Yeah. So, but the question's asking
Joke.
the sample mean of these student scores.
Oh, okay, I didn't do that part. I didn't do the square root of.
But am I reading it correctly though? Or is it just asking just for the z-score? Because I'm like, I don't think it's repeating the same answer as 6.
I'm going to figure it out on my own for a second just because I was so far off. So
Yeah.
I'm going to just disconnect first, or at least focus for a sec.
Yeah, you're fine.
Okay. Okay, hold on. What's the z-score? Okay, go ahead.
So there is just the z-score, but it gives us that they took the sample of 5 students.
Uh-huh.
And so I was wondering, are we finding the distribution of the sample mean where we do the 8.8 divided by the square root of, of 5, or are we just keeping it just the simple z-score?
That's where I always get confused, but since it gave us that, I'm going to do that. What would you do, Meredith?
I think we do use the square root of 5.
Uh-huh.
That was my thinking, and I got 2.338.
Yes, that's what I got.
Okay. Because I'm like, why would they just throw in all that information?
Yeah.
and it would be the exact same answer as number 6 if, anyways, that's what made sense to me.
Yeah, I agree. Let's just go with that.
Okay.
Good thing we have another try at this if we get them all wrong.
I know,
Oh my gosh.
seriously.
All right, number 9, are we ready?
Yep.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answer to 4 decimal places. So we just take that 2.338
Mm-hmm.
and just do what's above it, right?
Plug it into the, yeah.
Right.
So it would be 0.0097.
And do we need to, what was the rounding? Yeah, that's what I got.
Round to 4.
Right. Right.
Okay.
Okay.
So, wait, that was question 9?
Yes.
Because I had to change my answer, not change my answer, but I had to 0.0.
Work through it. Yeah.
0.097. And it's rounding to 4, so we're good.
Okay.
Okay. Are we on 10?
Yes.
Yes, ma'am.
Okay. What is the shape of this? Okay, suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It's well known that the distribution is left skewed and a random sample of n equals 81 students will be drawn. What's the shape of the sampling distribution of the random variable x bar, which represents the sample mean of the 81 students? Since it's a large number, it's going to be approximately normal.
Right. That's what I put as well.
Good. All right.
All right. So I could do question 11.
Okay,
Right.
big question mark.
This just says, what is the mean of the distribution of the sample means? This
Okay.
one, we're actually not working out anything.
Uh-huh.
We just go above question 10, and the mean was 3.5.
These catch me every single time. I'm like, no, I don't know how to solve for a mean. Did we ever learn how to do that? And then I'm like, oh, it's just the same thing.
Right. So
Oh,
I just
my
highlighted,
dear.
I just look for the distribution of the sample means. Or what is the mean of the distribution of the sample means?
Yes,
That
if it ever
keyword.
asks you for a mean, there's no way to figure anything. You
Right.
just have to put what it
Right.
is.
Okay.
Right. And it does. It tricks you.
Every single time. I
It
panic. I'm like,
totally
I don't
does.
remember.
So it is
Okay.
3.5?
Yes.
Okay. Good job, Jodi, for just doing what was there.
Well, it's tricky. I know. I have to reread these several times.
Okay. Is it my turn? I can't remember where
It's
we are.
mine.
All right, go ahead.
Meredith.
Okay, question 12. What is the standard deviation of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population? So that we just take the standard deviation and divide it by the square root of 81.
Mm-hmm.
Correct.
So that's, 0.7 divided by 9.
Mm-hmm.
And I got 0.078.
Yes.
Correct.
That's what I got.
Okay.
All right. What is the number 13? What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? Okay, so this is number 13. I got 0.005.
Yes.
Oh,
Yes.
hooray! Okay.
All right. So I am. Question 14. What is the probability that the mean GPA for 81 randomly selected BYU students will be greater than 3.3? So I plugged in the Z value that we got in the last one, but I highlighted the top two, right? And I got 0.995.
Yes.
Okay, hold on. I think I did something wrong. 0.05. I just need to plug that in.
Uh-huh.
0.005, right?
Yes.
No, so you're not plugging 0.005 in, you're plugging in your Z-score you got for 13 back into the applet, but you're highlighting the two to the right. It's above 3.
Okay, hold on.
Or you could just subtract 0.005 from 1.
Right.
Okay, hold on. Wait, what was the score that you got? 0.5?
0.995 was the answer to 14.
Okay, because that is 0.005. 1 minus 0.005 because it would have been, okay.
Correct.
All right. Okay. I think it's Meredith.
Oh, last one.
Yes.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, that was observed in the sample. Round your answer to 3 decimal places. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction. Okay. So we plug all those numbers into our equation. So we get 177.6 minus 185. Divide that by 26.7 divided by the square root of 48.
Correct.
So I got overall negative 1.920. Am I on the right track so far?
Mm-hmm.
Right. Mm-hmm.
Okay. So you plug that in, and then you take the far left and the far right, but not the middle. Is that correct?
That's what I did, yeah.
That's what I took it as well.
Okay, good. I wasn't as lost as I thought. Okay, and so that would give you a probability of, what are we rounding, 3? Of
Yes.
0.055.
0.055, yes.
Okay.
So just going back to this, just to clarify, so when it says as extreme or more extreme, so and then it says it's the lower and the upper, pretty much, right? For sure, like that's what it was, because the way they worded it was kind of confusing.
Yeah,
It was,
that was kind of a hint, I think to not forget to do those two. That's what I thought.
Right.
I thought he was just kind of giving that to us, but
okay,
with the 2 extreme sides.
All right. Well, I'm going to submit.
Okay, hold on. Before you submit, can I just, since I got a little confused when I was writing down my answers, and so I just want to make sure. Okay, so for number 3, we got 0.175.
yes.
Okay. For number 4, it's the middle one, the distribution of sample means. For number 5, it's the law of large numbers. For number 6, it's 0.1480.
No.
No, wait a second. 1.045.
Yes.
Correct.
Okay. 1.045. Okay. And then number 7, 0.148.
Yes.
Okay. For number 8, 2.338.
Yes.
Okay. For number 9, 0.0097.
Yes.
Yes.
Okay. And then approximately normal on number 10, and number 11, 3.5.
Mm-hmm.
Yes.
Okay. Number 12, 0.078.
Yes.
Okay. Number 13, 0.005.
Yep.
Yes.
Number 14.995.
Yes.
And number 15.055.
Yes.
Yep.
Okay. Great. Thank you. I'm glad I did that at the end because there was one that I hadn't changed. Okay. Did anybody submit? I'm going to submit.
It's thinking. Calculating.
100%. Good job.
Hey.
Thank you for helping me clarify those things, guys.
Yeah. How did you guys do on your homework quiz from the last one?
This particular
From 6. No, from 6.
that was a while ago.
It was. And I got 100%, but I was like, I don't know
job.
how.
Good
Because
job.
the wording was so confusing.
Yeah.
Like,
I got 100% too. I don't know exactly why,
right?
but
You're like, oh my gosh. Well, and then in our homework preparation for this one,
Mm-hmm.
what was the question where the answer was actually like, you cannot do it because it's like right skewed. It's not normal.
Because you can't use the normal probability applet for a right skew. Is that why? Is that what you're referring to?
That is right. It just threw me off because I was calculating and then I was like, wait, what?
Oh, that's frustrating. Yeah.
No, it's fine. I just was like, oh, I got to watch that question.
Did either of you do the homework for 7 or the homework quiz?
Not the quiz yet.
Okay. Well, I'm just warning you that I took it and I got like a 70 because it was tricky as well. I just felt like it was tricky, but so use your second chances if you need to. But then I took it again and I passed, or I got 100%. But it was a little worrisome at first. I'm not trying to scare you, but just, maybe I just am really good at doing it.
Well, it's just the wording. Like, you just got to watch, like the simple one that was just asking for the sample mean, that we already had. It's just, anyways.
Yeah. Okay.
It's identifying what they're asking for.
Yeah. Exactly. Okay, I'm going to stop the broadcast just real quick.
Well, you can stop it. Go ahead and stop. I just had a question.